Hi, my name is John, and for our Hudson Valley Climate Science Synthesis Project, we chose to explore climate change effects on water quality in the Hudson Valley. Here's a brief overlook of what we covered in our project. We studied climate modeling for increased intensified storm events in the northeastern United States, its impacts on water quality throughout the Hudson Valley, the drivers of degraded water quality, and mitigation strategies to address these changes. So why are we experiencing these intensified storm events? Well, there have been observed trends and model projections of increases in heavy precipitation that are supported by the well-established physical relationships between temperature and humidity. These trends are consistent with what would be expected in a warmer world, as increased evaporation rates lead to higher levels of water vapor in the atmosphere, which, in turn, lead to more frequent and intense precipitation extremes. The figure on the right depicts different emission scenarios and their impact on temperature increases. If emissions remain unaddressed, we could see a potential 7-degree Fahrenheit increase in average annual temperature. The figure on the right depicts how climate change will impact the Hudson Valley. At the top of the image, you can see that both the northeastern and Great Lakes regions of the country have been experiencing an increase in the total amount of precipitation that falls during the most intense storm events. From 1901 to 2016, there was a 38% increase in precipitation, and from 1958 to 2016, there was a 55% increase. The bottom half shows how precipitation will continue to change in the near future. If we can get our emissions under control and take steps to prevent climate change, the Hudson Valley will still be experiencing at least a 30% increase in the amount of precipitation falling in the most intense storms. However, if emissions are not addressed, this increase can be upwards of 40% or even higher. This figure displays historical precipitation data from the city of Poughkeepsie, and it's the daily precipitation events in inches from 1950 to 2020. It can be observed over the short period of time that the intensity of precipitation events or storms is increasing and will continue to increase well into the future. This graph, also from the city of Poughkeepsie, shows the frequency of the most intense storms every decade from 1950 to 2020. The white text in each bar displays the average precipitation in inches of each storm within the decade. It can be seen in this short and regional dataset that storms may not be uniformly increasing in frequency, but the intensity in daily precipitation per storm is increasing. The Hudson Valley is characterized by three primary land uses: forestry, agriculture, and urban space. Urban space is concentrated in areas such as Albany, Poughkeepsie, Newburgh, and Yonkers. Agricultural use is much more widespread, covering nearly 900,000 acres within the Hudson Valley. However, the most dominant land use in the Hudson Valley is forestry, which covers 75% of the area. The image on the right breaks down how these uses are distributed throughout the valley. As you can see, the urban usage, represented in red, and the agricultural usage, represented in yellow, is usually concentrated near water sources, represented in blue. Urban land usage is characterized by a lack of green spaces and widespread coverage of impervious surfaces, such as asphalt and rooftops. Precipitation cannot easily infiltrate through these surfaces, so it will collect and travel along streets and sidewalks until it can enter back into the groundwater system. An increase in the intensity and/or frequency of precipitation would result in an increase in urban flooding, a greater strain on sewer and drainage infrastructure, and higher levels of polluted runoff entering the water supply. Polluted runoff must be treated before entering stream networks, however, as otherwise the pollutants will be distributed throughout the environment. Forests have a much greater capacity for natural infiltration, but are still at risk from increased precipitation intensity. In mixed forest and alpine environments, such as those found in the Adirondacks, extreme precipitation alters hydrologic cycles and ecosystem processes. In broadleaf forests, more commonly found in the Hudson Valley region, extreme precipitation poses increased risk to riparian and lowland forests due to excessive flooding, inundation, and stream bank erosion. In all forest environments, soil erosion, flooding, and sea level rise will be prevalent threats. We all know the Hudson Valley is renowned for its agriculture, but due to increased precipitation because of climate change, this could have serious impacts on water quality for the region. A higher frequency of precipitation events will increase agricultural runoff, such as fertilizer, nutrients, and waste, washing into water supplies, such as the Hudson River. An excess of nutrients in the water supply can result in eutrophication, deoxygenation, and the disruption of aquatic environments. Now that we've discussed some of the land usage and the threats facing them, let's discuss mitigation techniques. To manage the amount of chloride from entering the water through sources such as road salts, we must change our winter weather practices. Methods such as anti-icing uses a salt brine to pre-treat roads prior to snow or ice events. This cuts down on total salt used and ultimately cuts down on the salt runoff into aquifers. All locations that need treatment should be assessed before treatments are supplied. Some areas, such as hill slopes, do not need as much salt as other places. Or, depending on the road surface, specific plows may be more effective than one general plow. In addition, roads located near important bodies of water, such as those that are water supplies or amphibian habitats, should be designated as low or no salt locations to limit the amount of runoff going into these important environments. The figure on the left lists alternatives to typical road salts that have less chlorine levels. However, these methods will still be able to affect bodies of water, damaging wildlife and water quality. Oftentimes, although more expensive, agricultural-based alternatives, such as those listed on the right, are the most environmentally friendly options. As a result of increased precipitation intensity, increased sedimentation will occur, which poses significant challenges for the functioning of our area's reservoirs. As reservoirs capture more of the sediments, downstream dynamics of the sediment transport will be affected. This will also result in a loss of reservoir capacity as the reservoirs build up with sediment. The Hudson Valley is highly susceptible to this due to the sediment buildup as a result of glacial till that has occurred over millions of years and the current deposits that are located in lakes. And if a reservoir is ever flushed, the now concentrated deposits of sediments will wash downstream, causing further damage and erosion. To address the damage caused by sediment transportation, watersheds in the Hudson Valley have received extensive funding for research on sediment management in the rivers and the reservoirs which supply New York City with potable water. Two watersheds, the Stony Clove and Warner Creek, have been studied for the effectiveness of sediment and turbidity reduction projects, also known as STRP. STRP methods include restoring streambed elevation and floodplain access, installing in-stream hydraulic and grade control structures, armoring stream banks with rock or riprap, and hill slope stabilization techniques. And that was what was performed, as you can see in the figure on the right, at Stony Clove Creek. The top image represents Stony Clove Creek before STRP methods were implemented, and the bottom shows a regraded slope and stabilizing vegetation, and the ecosystem is performing much better today. To address eutrophication and nutrient loading, it is best if farmers have less reliance on chemical synthetic fertilizers that are heavily based in nitrogen and phosphorus, and use natural fertilizers such as manure or other fertilizers made from organic matter. Unfortunately, there is not much that can be done to prevent the actual washing off of sediments into our water supplies. However, we can control the type of fertilizers we use to limit the amount of excess nutrients that will enter our aquatic environments. Thank you for taking the time to listen to our project. We hope that you can take away something from this project to implement in your community to help prepare us for climate change. Thanks again.